Good morning, everybody. Alright, today we've got a BMW DME. Now this is an MSV80, same as this one here. What we got this come in from a German specialist in Northern Victoria for us to inspect. It's an odd issue. Now it's setting a BSD fault code, so the BSD communication with the water pump. If we read codes, I can show you what codes. So it's a 2885 BSD missing message electric coolant pump. So that BSD missing message basically means that we've got no output control or no essentially communication, no input signal for the coolant pump. Vehicle's running hot, it's not commanding the coolant pump, etc. Now what we've done is we've actually cloned this ECU over, so we've written the VIN and the ISN and everything to a donor one just to get this car running, but we are going to see if we can at least diagnose and fix this one as well. Customer wants it done quick, so quickest way for us is to just get a donor ECU in there or a donor DME in there. Now what we've done, powers, grounds, communication wires pinned out at DME. DME is on and communicating, as you can see, so we can read all our codes, live data, etc. Scope's hooked up on the screen over here. So what we're going to do is I'll show you that our scope's working. I've got my channel 1 hooked up, and if we go to our cam wire, as you can see, we do have a good CAN high signal and we do have a good CAN low signal. Now, like I said, our communication's fine. Wiring diagrams, we'll go back over to the screen and we'll switch over to some diagrams on this side. There we go, diagrams. So we are looking for pin 26. So we'll go back. This is our driver sheet for this chip that drives this. Pin 26 is here. So we've got 3, 4, 5 and 6. Now it goes up to that little cap there, runs all the way up through to this chip. Now under the microscope, as you can see, this chip here, it's a 42C244. Now these are a common failure in a lot of the Mercedes ECUs. Obviously they're in these BMW MSV80s as well. What we're going to do here is we're going to confirm our feeds and our grounds and everything. If all looks well, then I'll most likely get a replacement chip for this one. So we'll get new chips stuck on there and see what happens. See if we have an output control and see if we can clear that code as well. Let's go back. So if you have a look at this, first things first, what we're looking at is our feeds. So we've got power pin is pin 20, and then we've got a whole heap of inputs and outputs, outputs. So pin 20 is power, pin 10 is ground. So if we go across here, we can see pin 20 is power, so we'll find opposite of pin 1, that should be a 5-volt feed, I'd say, and then pin 10 is directly down from that. So back over to the microscope, pin 20, there's our pin 1 there, where that little divot is, so that means that this is pin 20, and I'll pull up the scope just to show. So over here, as you can see, where are we, pin 20 there, we have a 5-volt feed. So that makes this pin 10 down here our ground, and we do have a ground on that pin. Now all these are outputs, etc. This one coming in here is the output for our coolant pump, I believe. Let's just have a look. Where are we? Yep, that's the one. That's the output for our coolant pump, and there is nothing outputting from this driver. So we're going to see if we can get a donor driver for this and just get it swapped over anyway. If the car's still around, we'll get it put on the car. If the car's not around, then we can basically swap this chip, see if we can then clear that code, and hopefully it will be all good to go. Alright, so hooked up the donor one just to show that we don't have the 2E85 DTC. So D1, D1, AC, CF, 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 FF. So we don't have that output control. So as I was saying, we don't have that output control fault in this donor DME. So I'm good to ship this off. This will get the vehicle running, and then I can order a driver in for the original one, which is now over there, and we can get that one all fixed, tested on the bench, and use it in another vehicle if we have to.